I am astonished by all that we know, from the bizarre behaviors of subatomic particles to the majestic expansion of the entire vast universe. I marvel that we really understand how the world works. But I chill, because much of what we today think fundamental, 150 years ago, we did not know at all. Is ours that special time in human history when all shall be known? Will we complete the puzzle of the cosmos? Or are there revolutionary discoveries yet to be made? Not refinements of current theories, but radical revelations and shocking secrets. Does physical reality go beyond what we know today? What's beyond physics? I'm Robert Lawrence Kuhn, and closer to truth is my journey to find out. I seek first-class scientists unafraid to tackle big questions. I go to Iceland, to a gathering of the Foundational Questions Institute. I begin with the director of the Origins Initiative at Arizona State University, Lawrence Krauss. As for big questions, Lawrence hits, how did the universe begin, and how did life arise?
Lawrence, quantum mechanics, general relativity, these are the great breakthroughs of the 20th century that have so changed our perceptions of what reality is.
Sure, absolutely.
Is it possible that there may be other things out there as significantly different now as quantum mechanics and relativity was once?
Fair statement is that the 20th century spoiled physicists. I mean, there was a time when in almost every single way our worldview changed.
Right.
Not just with quantum mechanics and general relativity, but we know there are at least 4 forces in nature. A century ago, we knew of 2 of them at best.
Right.
We didn't even know how to understand one of them with quantum mechanics. The progress has been tremendous. But at the same time, I can't help but think that there's much more we don't know about the universe than we do know. Every time we've looked out at the universe with machines, we've been surprised. And one great example is the discovery of dark energy.
Right.
Here is something that you could have asked any physicist a little more than a decade ago. We would have all been certain of what the energy of empty space was. It was 0. It's not 0. And it flies in the face of understanding. It also is going to completely change our picture of the future. For me, the most exciting developments that I expect is happening right now is the merging of physics and biology. In order to understand how biological systems work and how we exist, we are probably going to have to understand new physical principles, that the physics of biological systems may be different than the physics of tables or the physics of the universe. So I think we're going to find that the forefront of physics is going to move not just to these extremes of scale where I expect there will be surprises, but as we understand the phenomena that are central to our very existence, we may understand that we're going to have to treat science in a different way. It may still address a question that you might think of as fundamental, which we don't know the answer to, which is life a cosmic imperative? Or just a phenomenal accident? Are the laws of physics set up? It may be that to understand whether life is a cosmic imperative, we have to understand physics in a new way.
You would not be surprised by surprise.
I'd be surprised if there weren't surprises, put it that way.
But it has to stop someplace. Now, some have...
Why?
I've heard people say that. That doesn't make sense.
Why?
It doesn't make sense that you'll have an infinite progress, a Zeno's paradox of constantly more and more fundamental things.
Well, but what we've learned...
That sounds like a myth.
Well, no, what we've learned is what's fundamental changes. Okay? So that when we ask fundamental questions, whenever we come up with answers, what we find are more fundamental questions. It may be that the laws end and we have a theory of everything. In a sense, a theory that explains the origin of the universe and why the laws of nature seem to be the way they are. I see no evidence that's the case. But the question is, we don't even know now what the right questions are. Does the universe exist in many different states at the same time? If you'd asked that question a century ago, you would have been put in a lunatic asylum. I suspect what questions we think are profoundly interesting will continue to evolve, and I certainly hope it doesn't end. You should still be put in a lunatic asylum.
Lawrence is sure there is more to reality than what we know today. Fine, I'm with him. But, he says, there could be no bottom. More fundamental theories could go on forever. A never-ending series of deeper and deeper laws, like a Russian nesting doll, one placed inside the other. Lawrence thinks theories without end. I think that's absurd. But, much as I hate to admit it, Lawrence knows more than I know, at least in physics. So what might we find? I asked physicist Michio Kaku, who explores the far reaches of the possible. To Michio, little is impossible.
Around 1900, people talked about the end of physics. The US Patent Office was thinking of closing down because there's nothing more to invent. Then we had twin bombshells of the quantum theory, which opened up the world of the atom, and general relativity, which opened up the universe, black holes, space-time. And then we realized that we were so naive around 1900 to think there was an end of physics. Now today we ask the same question, is this all there is? I don't think so, because you see, we have these two great theories, but they don't talk to each other. They don't like each other. They hate each other. Why should nature be schizophrenic? Why should nature create two bizarre theories, one for the big, one for the small, that don't talk to each other? So I think we are bound for a new paradigm shift on that scale, a theory which goes beyond just relativity, a theory which goes beyond the quantum theory. And then, of course, we can ask another question, what happens beyond that?
Well, it would seem that the regress has to end at some point. Some have said that it can go on forever. Conceptually, I don't see how that's possible. At some point, this has to end.
Well, there's several ways of looking at it. One is the onion theory. You see layer inside layers, which seems to go on forever. Each time you probe a new energy, you have a new layer of physics. But there's the other theory of the North Pole. The ancient mariners would draw a map without the North Pole. No one had ever visited the North Pole. Well, we've now found the North Pole. There is an end. The Earth is not limitless. I tend to lean more toward the North Pole idea, because all the compass needles do point to a theory of everything, and at that point, it would stop.
What can the far future become in terms of possible things that seem impossible today?
Some people say physics stops at the Big Bang. You can't go below the Big Bang because there's nothing there before the Big Bang. Well, we physicists have many models of the pre-Big Bang era. A new generation of machines are coming online which may answer these fabled questions of what happened before Genesis. How will doomsday unfold? Is it possible that there are other universes?
Let's look at the physics of the impossible, things that today seem ludicrous, things that seem to defy all physical law today.
When people say, bah, humbug, that's impossible, what they're really saying is that's impossible with today's technology. But what about 100 years in the future? What about 500 years? What about 1,000? What about 1,000,000 years in the future? Look at invisibility and teleportation, two staples of science fiction. Any physicist would snicker and laugh. Ha! Invisibility, teleportation, beam me up, you know? Well, we've actually done it now. We've actually, on microwave radiation, made objects invisible. And now we're testing it on visible light now for the first time. Also, teleportation. We can teleport individual atoms. Now extend that maybe 100 years in the future. And then you begin to realize, hey, you know, the stuff that we used to consider science fiction and laugh at, well, that's going to become perhaps the reality of the future.
In seeking reality, Michio maximizes science, envisions what hyper-advanced technologies could do in the future, what would seem to be utterly impossible today. Michio is a visionary, but still he stays within the bounds of known physical laws. That's where he's comfortable. As for me, I go for discomfort. I do not like to be ridiculed, and I will be tough-minded, but I seek to break the bounds of known physical laws. It's probably impossible, but still I must try. Very few scientists go beyond today's realm of the physical. One lives in England, a botanist by trade, an iconoclast by reputation. I go to Oxford, to the Pitt Rivers Museum, to meet this off-the-edge scientist, Rupert Sheldrake. In Driving Reality, Rupert sees strange new laws.
A lot of people think that we have an evolving universe, but at the moment of the Big Bang, all the laws of nature were there fully formed, like a cosmic Napoleonic code. I don't think it's like that at all. I think the laws evolve along with nature. And in fact, I think the term law is a really bad term for them, because law implies a human legal system. It's a human metaphor. I think a much better term is habit. So my view is that the universe evolves, and with it, the habits of nature. So it's radically evolutionary, it's full of habits, and also creative, because evolution depends both on repetition, which is what habits do, and creativity, which is where new things come from. If you just had just habits, nothing would change. If you had just creativity, you'd have a kind of chaos of innovation with nothing stabilizing.
What are some of the exemplifications of that or implications?
If you make a new chemical compound, that's never been made before, as far as we know, that's something new in nature. If you crystallize it, that's a new form in nature. So when the crystal first forms, it hasn't got a habit. And it's actually rather hard to get crystals to form for the first time. Anyway, you get a crystal sooner or later, and then it gets easier all around the world to crystallize these things on the whole. Chemists have known this for years. I would say this is a new habit getting established. The more often it's done, there's a kind of memory of the previous crystals.
So your vision is that somehow making that first crystal embodies that form in some super field sense, as opposed to just the common human ability to do things because other people have, they read about it, and they learn how to do it better and better.
That's right. My hypothesis is that it happens by a process that I call morphic resonance. Morphic resonance is the influence of similar patterns of activity on subsequent similar patterns of activity. So what's important is similarity. And this moves across space and time. So it's a kind of cumulative memory. The first time you make a new crystal, there isn't a field for it already, but it comes into being. The second time, it's influenced by the first crystals. The third time, it's influenced by the first and second ones. The fourth time, by the first, second, and third. So it builds up this influence by morphic resonance. So each kind of thing, each kind of crystal, each biological species has a kind of collective memory on which each individual draws and to which it contributes.
And these fields are universal?
They're universal. Once they've occurred, this influence of morphic resonance can happen anywhere. Everything in nature organizes itself, and I think that each self-organizing pattern of activity has a morphic field and a kind of collective inherent memory. Teach a rat a new trick in Oxford, or better, teach hundreds of rats a new trick in Oxford, and rats of the same breed all over the world should be able to learn the same trick quicker. Teach people a new trick, a new video game, a new sports technique, and it should get easier for people to learn all around the world. So all the sort of easy explanations, better nutrition, better brain, bigger brain size, more exposure to television. All these things have been considered, and none of them can explain more than a small part of this effect. Right. So it's a genuinely mysterious phenomenon that fits perfectly with a morphic resonance view, and it completely changes the way we think about the world.
Well, few scientists think the way Rupert does, conjuring up organizing principles that almost certainly do not exist. But that Rupert is wrong does not prevent my enjoying his disruptive ideas. expanding my boundaries, confronting ideas I'd have never imagined, like being freed from a prison in which I didn't know I was being confined. I scurry back to mainstream science, but with a fresh openness to consider radical ideas. I meet a cosmologist who boldly addresses questions many think unaddressable, Paul Davies. Paul wonders whether the laws of nature are from forever.
Very few of my colleagues would agree with the fact that the theory of relativity and quantum mechanics are somehow the last word. It clearly is a stepping stone, an important one, on the way to some deeper level. And so, for example, space and time, are these truly primitive entities, or are they built out of something else? Particles of matter, we're pretty sure, have building blocks inside them, maybe little strings, maybe something else. And then there are deeper issues like quantum physics. It's the one thing that all physicists seem pretty certain about, is that whatever comes beyond our present theories will be cast in a quantum framework. But one can still ask, why quantum mechanics? Why is that the last word, or is there some other way of describing reality? If it doesn't have to be that way, is there something special about that particular setup? And I think the answer is yes, there is something pretty special about three space and one time dimension, about the set of particles that we have and the forces that bind them together. So we need to understand where all these things have come from. And the only way to do that is to have some deeper level of reality from which they emerge. That's really tough. Could it be that somehow everything about the universe is captured just by that two-dimensional surface, the information on that surface? In other words, there's far less in the universe than we really thought. It's like a hologram. A hologram is a two-dimensional surface. You shine a laser on it, you get a three-dimensional image. So could the universe be a three-dimensional image of what is really two dimensions? The physics on two dimensions. And if we combine that holographic principle with some other principles, maybe we'll have a totally different view of physics. So what we have now is an image of the universe where instead of regarding matter as the primary stuff of the universe and information as being a sort of secondary or derived concept, we're thinking that maybe the information is the primary content of the universe, and that matter is the derived thing. If we think of the universe now as a gigantic information processing system, then the laws play the role of software and the universe plays the role of hardware. And that to me suggests that the laws of physics have a finite accuracy, a finite fidelity, a finite precision. And so this suggests a view of physical law, instead of being stamped onto the universe from without, like a maker's mark, infinitely precise laws, boom, there right from the beginning, from the Big Bang. Instead, the laws are inherent in and emergent with the universe. So they start out sort of fuzzy and unfocused and zero in over time. More information becomes available, these laws become better and better defined. So the laws are now within the universe and not magically imposed on it from outside. And that traditional view of the laws being imposed from without is essentially theological, I might say. It comes from the idea that there was an external lawgiver God who made a universe and imposed laws upon it from outside. Physicists have by tradition, bought exactly that image. They say, well, the laws of physics are not in the universe, they're outside of it, and they're imprinted on it at the moment of birth, and they're fixed, immutable, universal, absolute laws. And I think that the time has come to abandon that idea, that we appeal to something outside of the universe to explain the laws that are within the universe. I'd like to have an explanation from entirely within the system, based on the notion of information as the primary entity out of which everything is put together.
To Paul, the reason for the laws of the universe must be contained within the universe, not imposed from without, not by a creator God, not by almighty physics. And these laws, which Paul says can change, are at their core information. His universe pulls conventional wisdom inside out, exposing gaps in common explanations. Paul's got guts, and I go with his gaps. but not with his theories. If all reasons are to be sufficiently subsumed within the universe, something about the universe must be self-existing. But what could even count as a candidate? What about consciousness? Some scientists assert that beyond the physical sits consciousness. That the bedrock of reality is a kind of mind, but not necessarily a kind of God. I ask David Chalmers, an Australian philosopher of mind, who returned respectability to the ancient idea that mind is more than brain. David speculates that what's fundamental in the cosmos may be consciousness.
Consciousness is a natural phenomenon. I'm conscious, you're conscious. It's a fundamental fact of our existence. So I think our scientific theories ought to acknowledge it. One of the basic mysteries of consciousness and science is how does consciousness fit in to the natural order, if indeed it's a natural phenomenon? You could think of quantum mechanics here as offering a really interesting hypothesis, which is here is the role of consciousness in the physical world. It collapses the wave function, makes the indefinite definite.
So you are, in a sense, adding consciousness to the physical world, or maybe the better term that you use is the natural world, because you don't need any non-natural persons like gods or angels or beings to make this work.
No gods here, no spirits, no spooks, just consciousness, a natural phenomenon. Maybe someone thinks our best science says all that's real is physical, but now it looks like our best science has to bring in consciousness for at least potentially two reasons. One, to accommodate the very fact of our consciousness. We're more sure of it than of anything in our existence. And two, maybe, to help explain quantum mechanics. If so, that gives us two converging reasons to believe in a fundamental natural consciousness.
I'm still slightly troubled by the difference, if there is one, between naturalism and physical world. Are they synonymous?
Physicalism is the view that all there is atoms in the void, so to speak. There's space and time and particles with mass and charge and maybe a wave function over them. And naturalism, on the other hand, is a broader thesis. The world is ultimately simple. Complexity is generated by simple entities obeying simple laws. And what this case shows us is those two things can come apart. Maybe we have reasons to go beyond the physical, to go beyond atoms in the void, to include consciousness. So that's something else. But the world is still ultimately natural, still invokes simple entities, fundamental properties, obeying fundamental scientific laws. It's just that those laws have been expanded now to include consciousness. So I would call this naturalism, but not physicalism. Well, I'm just basically taking the good scientist's attitude here. I was brought up a materialist. I believe only in what you have reasons to believe. Don't multiply entities without needing to. But consciousness, you had to bring it in.
You need
Absolutely.
to multiply something to go from the physical world to the broader natural world.
So let's bring in a new property. You might say this is an expanded physical world, or you could say it's a physical and mental world. I don't care. What matters to me is that it's a natural world with expanded natural properties. Yes, the universe contains more than we might have thought originally that it contains, but it's still an ultimately natural world, scientifically investigatable and governed by natural laws.
Here's my take on physical reality. Is there an ultimate theory that explains space, time, matter, and energy? Yes. Underlying laws or principles cannot continue forever. Are there sweeping new laws of nature which will alter our sense of reality? Probably, but they'll be more unifying than disruptive. Do laws evolve? Possibly, though I doubt radically. Does the physical world, as we know it, exhaust reality? No, there is more, but I know not what. Now, what about consciousness? To me, it's the test case, the probe of the reach of reality. Consider three possibilities. 1. Consciousness is purely physical, and there is nothing left over to explain. 2. Consciousness requires profoundly new physical laws or stuff. 3. Consciousness cannot be entirely explained within the physical world and must include non-physical or spiritual elements. What do I conclude? There's more to reality than today's physical world. That's as far as I go, for now, getting closer to truth.
For complete interviews and for further information, please visit closertotruth.com.